Tell David how you feel about him.
David, I hate you.
Whoa,
Just
whoa,
kidding,
whoa,
just
whoa.
Kidding, just kidding, just kidding.
Inappropriate.
David, you're great, and I love you, and you're my best brother ever.
All right, cool. And none of your parents are going to mind if you're on YouTube, right?
No.
No.
Ethan?
No.
Okay.
And my parents would be like, whatever.
All right.
Whatever. Do you do that with your phone every time?
What?
Like, you
I've been doing it for
from
Algebra
your
1
phone?
lessons, streaming lessons to YouTube and having them watch the lesson at home.
Exactly what's the name of your YouTube so we can find it?
You just Google search my name. It's my personal YouTube channel.
Jacob Boyer.
Yep.
Okay.
Jacob.
Your last name is fun to say.
Weird.
Weird.
Boya.
Okay, we're on Unit 3, and here's what I want to challenge you to do, okay?
Oh no.
I want you to be building a study guide today.
Okay.
How is
So what I'm going to do first is, I'm gonna write on the board all the modules, because we like went over those exercises yesterday. You went home and did them.
Correct.
It was good after we went over it yesterday.
yeah, because
Okay.
Yes, right.
So let me just write everything that we've done in modules 5, 6, and 7, okay?
And weird.
Module 5 is graphing cubic functions and graphing polynomial functions. So that was a while ago. So remember though, this was things such with the cubics, polynomial. With the cubics, it was more translations. So understanding what the parent y equals x cubed function was, and then being able to stretch it or slide it around, right? So that was primarily what we did here. And you'll want to go back and look at that. And remember what a, b, h, and k are and stuff like that. And what happens if it's inside the cube or outside the cube. So if it's inside, if it's being cubed, it's operating on the x, it's a horizontal characteristic. If it's outside the cubed, so you would have a situation where a is like being multiplying by some expression which being cubed plus k. Inside the expression that's being cubed, there's going to be b and h, okay, operating on the x, right? Okay. Then graphing polynomial functions was where we started to learn the characteristics of functions such as zeros, mins, and maxes. Remember? So that's just ringing a bell.
yeah.
Okay, fantastic. So that is module 5. A black marker. Module 6 is a long one. So let's see there. I will warn you, this video, the last video that I posted for Algebra 1, they said was like unwatchable. It was so fuzzy and everything.
Oh.
Because we're relying on the Wi-Fi connection, so if the Wi-Fi connect, it'd be awesome. Then as long as no other teacher is using it, I would be willing to like stream every class. I think that would be awesome, right?
Yeah.
Yeah, awesome. But that doesn't mean you don't have to take notes. You should still take notes. Okay. So module 6. 6.1 is adding and subtracting polynomials. Okay. 6.2 I believe is multiplying. Yep. Uh, 6.3 is the binomial theorem. 6.4 is factoring polynomials. 6.5 is dividing polynomials. So this is where we started to get into synthetic substitution and synthetic division. Okay? then finally module 7. So what I like to do when I'm trying to kind of review a whole unit is look at the big picture, and kind of then, now that we've covered everything in detail, we're trying to get the picture of, like, what overall were we doing in this unit? So that's why I'm writing all this on the board. Finding rational solutions of polynomial functions, or polynomial equations. And we're going, okay, we're starting to understand how polynomials quadratics. So only going up to a degree of 2, right? So now what we're doing is going, okay, now we're transitioning out of just begins with cubics. And then we expand that real quickly into everything else. And going like, okay, you can kind of understand how it works when it's not just a parabola, when you deal with cubics. And then, but we didn't go very far with that. We just understood zeros, mins, and maxes for the most part, and behavior. Then down here, we start dealing with polynomials, not graphically. This was mostly graphically, but this is all algebraically. Okay? So we said, how do we do the arithmetic of polynomials? Right here, their binomial theorem is expanding a power of a binomial. Right? Then we start taking them apart by factoring and dividing. And that was so that we could figure out how to find the zeros, the roots, the solutions, all sort of synonyms, okay, for different contexts. So this was all understanding the shape and makeup of polynomials. So what of that, when you read the name of the lesson, makes your heart rate increase? Meaning, looking through the lessons and building yourself a study guide. Writing down formulas, theorems, stuff that you need to make sure is in your brain before Monday's test. So what do you think?
Probably the early lessons.
Okay,
I don't even remember.
module 5.
So long ago.
Yeah.
So let's go take a look at module 5.
Years gone by.
Okay. So this is a brief question and aside.
Money, and I'm sure my parents.
Again, I told you the story of how I figured out that we didn't need them. I asked a teacher friend of mine, who was my teacher, and he said he doesn't require them for algebra 2. Well, he doesn't lie. He's just a different kind of individual, and so it might just be easier moving forward to have them. All right, and then I would recommend that you get this one. It would make it easier, and we can look at things really quickly. So let's look at page 268. Assessment readiness. It's probably not in your notebook. Okay. So what is the vertex of the parent function y equals x cubed? Like in a parabola, the vertex is the bottom.
Curved.
I'm just pointing out it's not a min, but it is like it's where the so it goes like this. Right? Okay. And that's right there. So the question is, where's the vertex of this function?
-6, 2.
Nick, is he correct or incorrect?
He is 100% correct.
So tell me about Nick, how he was able to figure that out.
Because if it's in the middle and you're adding it like that, then, well, if you're adding it, then it's gonna move it to the left, and if you're subtracting, it's gonna move it to the right.
On when it's inside.
Yes,
Okay.
and then,
Your explanation. Good. And again, because I always think about like when we're operating on the x, adding 6 means we're going to get to the y faster. So that means all my x's move left to compensate for getting there faster. But again, that's just how my brain works. B is y equals 5x cubed plus, and or you can tell me, what is the 5 doing, what is the 7 doing?
The 7 is moving the graph up 7,
Mm-hmm.
and then the 5 is making it stretched out
Which way?
this way, this way, this way.
Mm-hmm.
Okay.
And this one's tricky, because essentially this is like this, okay? This is 5, 1, x plus 0 cubed plus 7. That's what it is. So,
it's working on the y.
right, 5 is operating on the y. And I'm gonna, because, notice, with what we understand about order of operations, this 3 is only operating on this. It's not operating on this, right? We see that clearly. And so this is A, B, H, and K. Okay? So B and H are only the things that the exponent is operating on. So that's how we figure that out. Cool? But that one was tricky, icky, because that 5 is really close to that x. Notice as I was writing, I even subconsciously left. Finally, x minus 4 cubed plus 2. And everybody, like, jot down your answer so you're all doing it independently. X minus 4 cubed plus 2. Where's the vertex? Well, after you've written it down. You can just write the coordinates of the vertex. Everybody done? Kennedy, what do you say?
42.
Nick? Ethan?
4, 2.
Perfect. Good job. Yep, so this is a negative 4, but it's operating on the x, so we undo it by moving right, and this is operating on the y, so we move up. Fantastic. All right. So that is 5.1.
X minus 1. X plus 3 squared.
So knowing what we know now from module 7, how many zeros does that have?
2.
5.
No, 3.
3,
Wait, hold on. 1, 2, 3.
4.
Yeah.
4. Because the degree of the polynomial is 1, 2, 3, 4.
Oh.
Okay? But it has, so the zeros are 0, 1, -3 with a multiplicity. So true or false, there are 4 turning points in the graph.
True. No, turning points.
Turning points are where the slope changes from negative to positive or positive to. So, false.
There's only 3 turning points.
It'll look like the.
I think it's like this. But no, it's because it's to the 4th, so that's not right. Let's see, x times x minus 1. Right, it'll just do a Wentworth there.
Oh, what?
X plus 3 squared. So yeah, since it's to the fourth power, that's touching the x-axis, something like that. Except that max is like that. Okay. So the turning point, the graph crosses the x-axis at -3, -1, 0, and 1. True or false? Yeah. -3, +1, and 0. That's where it at least touches the x in there. And the graph has a global max. True or false? Remember, is the function continues out to the infinities. So if it's going up anywhere, if it's going up to infinity anywhere, there is no global max. There is a global min on this because both ends go up. Okay? The only way you can have a global min or a global max is an even function, which is a function of even degree, which has reflexive, well not, yeah anyways. So the first part we did, translating cubic functions, we're looked at all the charts of end behavior, and we looked at distinct factors, just little exercises from this section again. And a note, like when they say for all p of x equals, be like, look at it and go, oh, they're talking about a generic polynomial. Okay, generic polynomial, these are the rules. So what happens sometimes when we're dealing with math language, it's inside, so it's on the x, so you go backwards, and it's outside, so it's on the y, so you go, you get the gist of what they're saying. That's good, right? So you can still read it for understanding. Does that make sense? So that will remind you, and again, primarily we're looking at how do we find end behavior, how do we find mins and maxes, how do we find zeros, where the graph crosses the x-axis. Okay? I would almost be tempted to take this and put it here, but whatever. Understanding this is helpful to understand. I don't. Alright. How about in module 6? Okay. There were a couple. I'll just remind you to be very meticulous. So choose one of the two ways to multiply the fifth. I can make one way, I'll do that here. X to the fourth, I can make another way, everything else. Then this one, by everything else. Then this one, by everything else. That's the other way to do it. Okay? But then your like terms. So on these, it might be helpful to look at your quiz to see if you made mistakes. Begin there, and then go back to the book and the homework exercises.
That'd be cool if he was watching it right now.
Yeah, I could have told him he could have, and then he could actually interact. I would have had one of you like they're responding to.
I don't think that it's that bad.
Okay.
I'm just remembering the process of like making.
Yeah. It's over. So, right? Is that accurate?
Yeah.
I'm not misreading the situation.
No, you're right.
Okay. But just to know that it's that how many ways is the combination. That's where that number is coming from. So that's cool. It is as well as on some of the homework. Was to just set it up. Okay. Yeah, this. One is like x plus y be like 3x plus 5y. Or let's make it easy. One of these terms would be 5c3 x squared y cubed. MCR3, 10. So this is equals 10 x squared y cubed. And once I calculate each of these, I'd be done. There's no more multiplication to be done here because I don't have a value for x or y. Okay? But then to the third is 343. So I'd have 10 x squared times 343. That's the term in the binomial expansion. So if this a term is 5c3, 3x squared 2y cubed, okay? Squared times 8y cubed, okay? Not done, buy it all the way down. So this is how you set it up. This is using the binomial. Make sense? And like, right? I had somebody on the quiz. It's so hard because there's only 4 people in this class. So don't do that. That's because here, right? If this is just a letter and a constant, then this is your A, this is your B. So I plug in A here. Okay. So that's binomial. The second letter on the combination, or the second number on the combination, is the exponent on B, because then I start at 5c0 and start this at 0. And then this goes up as this goes up, while this goes down. Right? Everybody follow what I'm saying? Kind of. So I'll show you both ways, but I like to do it this way, and we'll call this to the n. Okay, a plus b to the n. So this is the most generic way we can talk about the binomial theorem. I like to go NCR, or start at NC0, okay, a to the n, b to the 0. So my r here, in combination language, this is n and this is r. My r is always the exponent on b. That allows me to start at 0 and go up, which feels the most natural, right? And keep these in the standard form order, where a is a descending power and b is an ascending power, 0. And keep the r consistent with the exponent on a. That's what I'm saying. It doesn't matter. You can do either way. I like this way better. Agreed? Cool. All right, so that's binomial theorem. How do we feel about factoring and dividing? All right, briefly. Well, no, just write those down and memorize them. You want to do a couple?
Yeah.
Okay. This is the one that set me off. So, what do I do first?
Pull out 5x.
Pull out 5x. Okay, is it factored? Why not?
Because you can factor. No, you can't. I don't know.
Okay. Okay, and I expect you to memorize are a perfect square trinomial, so a plus b squared, what that results in. Difference of squares, a squared minus b squared. That is an identity to memorize. Sum of cubes, a cubed plus b cubed, and difference of cubes. So there's 2 for a square, perfect square, there's 2 for a cube. Okay? So there's perfect square trinomial, which factors into a plus b squared. There's the cubes. Is this any of those 4? Sum of cubes. What is the cube root of 8x cubed? So perfect cubes are 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 1. Okay? So that would be helpful if you could do that. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. Okay? And we did earlier 7 cubed is 343, but I don't have it memorized, we just did it earlier, that's why I know it. Okay? So now this, I go A plus B, and then I go A squared plus AB, I believe, I'm going to double check this in a second. So AB is 2x, and plus B squared, which is 1. Okay? Yeah, sum of 2 cubes. Nope, that's a minus. So this is minus. A plus B times A squared minus AB plus B squared. Okay? So the nice thing about this is it's just a variation on the perfect square trinomial. So if you've memorized the perfect square trinomial, which is A squared plus 2AB plus B squared, which is intuitive when you're factoring A cubed plus B cubed. And for both of the cube identities, so now that's factored. So, this is sum of cubes. So the first thing I'm going to do is A plus B when I factor it. That's sort of intuitive. A cubed minus B cubed. First thing I'm going to do is A minus B. Again, intuitive, right? Feels right. Okay? Now notice, in both of these cases, I'm going to multiply by some trinomial. Alright? So there's going to be a term, like to make A cubed, I need an A squared term. To make B cubed, I need a B squared term. But I need some way to cancel my AB term, plus AB term, so those terms in the middle cancel out. Okay? So now this is, I need an A squared and I need a B squared to get to an A cubed and a B cubed. In the middle I need some things to cancel out, so since this is a plus, I'm going to write minus B cubed, I need an A squared and I need a B squared. Okay? This is negative, this is positive, so when I multiply these two together, I get a minus B cubed, that's what I need. But now I need the terms in the middle to cancel out, so I'm going to take this sign and do its opposite times AB. Okay? That's where that comes from. But not tough to just memorize. Okay? Factors to A plus B squared. And then difference of squares, A squared minus B squared is just A plus B, A minus B. Okay? So that's special factoring patterns. Let's do one more. Let's factor by grouping, huh? X cubed plus 3x squared plus 3x plus x cubed plus 3x squared plus 3x plus 2. Right? Yep. Okay. So that would be tough to factor any other way than by grouping. Oh yeah, this was the funny one. Funny one, funny one. Not even fair, really. Oh, and they had a typo. Yeah. Lane. Okay. We're gonna just. Oh no. Okay, I see the typo. It's in my book. It's in the solution. They have a typo. So. Yeah, this is so dumb. Okay, we'll do a different one here in a second. But what they did was they took one of these off, x cubed plus x squared, and made that a group, plus 2x squared plus 3x plus 2. So that's just hard to see. So I will preview your quiz on anything like that, or your test. try to see, so that, because that's just not fair. So this factors into x plus 2 and x plus 1, plus this factors into x squared and x plus 2. So now I have a common factor of x plus 2. So wait. Yeah, that's right. And that's it. So that one's kind of crazy. And just to be clear, this was a hiccup on the quiz as well, is that irreducible just means it can't be factored. Is everybody clear on that? Irreducible just means it can't be factored. They're either irrational or complex. If it can't be factored. If it can be factored, that means there are real rational zeros. Yeah, so here's an easier example. X cubed plus 8x squared plus 6x plus 4. Okay. So typically, grouping, we're just going to go group, right? So out of here, I'm going to pull x squared. Out of here, I'm going to pull 6 and x squared plus 6. And what you have to look out for in these is to make sure that this is not further reducible. In this case, 6 is not a perfect square, so this is not a sum of squares. And sum of squares would be a perfect square trinomial. But if this were minus 9, you'd have a difference of squares, you'd have to factor that. Okay? Let me see that.
Yeah.
You got it, Nick?
Yes.
Okay. For instance, 14 says x cubed plus 4x squared minus x minus 4. X cubed plus 4x squared minus 4x minus 4. Is that what I said?
Minus x minus 4.
Minus x? Yeah, minus 4. Okay, minus x minus 4. So now we group and group. Okay, so we have pull out x squared. You have x plus 4, and pull out negative 1. Yeah. So I just factored this. I have an x plus 4 factor. I want an x plus 4 factor here. So I pull out minus 1, and I'm left with x plus 4. X squared here. Oh, look, I have an x plus 4. Is there a way to get an x plus 4 out of that? You can ask yourself that kind of question. Okay? So now I'm left with x plus 4 times x squared minus 1. And just to reiterate, going from here to here, I'm using the distributive property. Does everybody see that? Okay. Because I'm distributing x plus 4 to the x squared and to the negative 1. I'm just going backwards. Now this, though, is a difference of squares. So that's where I go x plus 4. And this is a squared minus b squared. So I go a is x plus b, and then b is 1, and x minus 1. So difference of squares, a squared minus b squared, factors into a plus b, a minus b.